All right, lesson 7.5, we're going to begin factoring. And the main thing to remember in this lesson, we have a leading coefficient of 1. Everything will have a leading coefficient of 1 for this first introduction to factoring lesson. So we're going to learn to factor these and then do some real life problems. So there's basically two situations that are happening. We either have a polynomial where C is positive or a polynomial where C is negative. If C is positive, we have these two likely situations when factored. So we're taking them from the trinomial into the two binomial products. So we're kind of working backwards from everything that we've done so far. We've already multiplied these. We've already did the double distributive or FOIL or whatever method you want to get a trinomial answer. Now we're going to take this and figure out a way to come up with the two things that were multiplied together. So if C is positive, right, C is the last term. So in a trinomial, we usually have our A, our B, and our C terms, the three terms. So we have a positive C, then we could either have positive B or a negative B, and that's going to change the outcome, but the concept is just the same. And so we're going to focus on what the concept is, and then it really won't matter what's happening with your B's and your C's. Okay, so let's see what this is going to look like. So we want to factor this. So the first thing you want to do whenever you are doing this, your goal is to find factors of C that will sum to B, whatever the B term is. So remember we said this is our A term, our B term, and our C term. So we've identified that B is 10 and C is 16. So we need two integers right here, looking down here, find two positive integers that are factors of 16 and whose sum is 10. So you get to puzzle it out. You just get to look at and list. You could either list all the factors of 16, or you can just say to yourself like, oh, wow, 16, 8 and 2, and go right to this idea, because these are your two factors. So that means you write them as a binomial, x plus 2 times x plus 8. And then if we check our work, the first terms multiply to our x squared. The outside terms give us, so we get x squared plus 8x. Inside we get plus 2x. And then finally our last terms give us that 16. And you can see that the common terms that we want to combine, the like terms to combine, sum or add to this 10 right here. And of course the last two multiplied to 16. So this is where they're all being connected. Let's give it a try. Now if B is negative, we're looking, remember, because two negatives can be equal to a positive product. So if B is negative, then we're dealing with both negatives. So again, you're looking for the factors of 12 that are going to sum to a negative 8. And in this case, we know they're going to be both negative factors. Negative 2 times negative 6 will give us a product of positive 12, and negative 2 plus negative 6 give us a sum of negative 8. And then we can see that we have x minus 2, x minus 2 times x minus 6 here. So I'm going to move right along to where we can get to our practice. So again, factors of 7. So we're looking for factors of 7. We know that that's 1 times 7. And because it's relative or it's prime, that's really the only other factors. So they're both positive, and the sum would be 8. If you add 1 and 7, you get 8. So you know that it is C plus 1 times C plus 7 as your binomial factors of this trinomial. So you could always check it out. Here, we need factors of 64. So if we start listing the factors of 64, this is what I like to do. Listing the factors of 64, we would have 1 times 64, 2 times 32. 3 is not a factor. One of the reasons, if you remember divisibility rules, when you add 6 plus 4, you get 10. And in order to be divisible by 3 or 9, it has to be like a multiple of 3 in order to be divisible by 3. So 64 is divisible by 4. We have 4 times 16. And then let's see, not divisible by 5, not divisible by 6 or 7, but it is divisible by 8. And you can see right here, 8 plus 8, right? So we're looking for the sums. So you might, be able to do this in your head as your first guess of your factors, but sometimes you just need to think of a couple different ones. And so we're listing all the factors of 64 to see which one is the possibility. So because 16 is positive, these are both positive, we would have a plus 8, and then that would be times a plus 8. And hopefully you can also recognize this very similarly to our lesson 7.3 when we looked at those special products and the patterns. This does follow that pattern because the coefficient, the leading coefficient is 1, which is a perfect square. C is a perfect square. Therefore, we could get to this pretty easily. That must signify the end of school. All right, so here we go. We can just leave our answer like this. So I want to let you go ahead and try number 3. So look for the factors of 18 that will sum to 11 and record your answer. All right, the next concept is when C is negative. When C is negative, sometimes B is positive, sometimes B is negative. But when C is negative, you'll have one positive, one negative. Obviously, the absolute value, whichever one has a higher absolute value, like here, the negative number has the absolute value that is higher, that's going to give us a negative B. If the positive had a higher absolute value, we would have a positive B. So that's going to be and determine right here. So we know that the positive value has to have the higher absolute value. So we're listing the factors of negative 21 to get a sum of 4. So sometimes you'll see people, teachers or other videos and lessons, they'll kind of like give you this diamond pattern and they put the product here. So it's negative 21 is the product, right? That's C. C is a negative number. B is a positive 4. So you want factors, we want the two numbers that go here that are factors of negative 21, but when you add them together, you get a 4. So, listing the factors of 21 in your head, you have like 1 and 21, it's not divisible by 2, but 3 and 7. So we know that we have, 3 and 7, and the difference between these is 4. So since it's a positive 4, we know that we want the 7 to be the positive value, and we could do the negative 3. Another way is making this table and then actually writing things down like negative 21, positive 1, negative 1, positive 21, because you have all these possibilities and then checking the sums. But if you want to summarize your work in a little diamond box type thing, little X marks the spot. So that means one of our factors is a negative 3 and one is a positive 7. So negative 3 and positive 7, x minus 3 times x plus 7 would be our factored form. All right, so let's give these a try. We're looking for factors of negative 54. So again, sometimes, since it's negative 54, we know we're going to have one positive and one negative. That's the only way to get a negative product. So we can just list the factors and then we can kind of play around with which one's going to be negative or positive. So we have negative, and I just said that and then I read a negative. Well, that's just Mrs. Kleiman. 1 times 54, we're going to have 2 times 27. Because 5 plus 4 is equal to 9, 3 is also a factor. We have 3 times 18. And remember that one of these is going to be negative, right? We haven't decided which one yet in order to get our positive 3, but we're just listing them to try to, we're still not anywhere near finding the right ones. Let's see, not divisible by 4, 5, but it is divisible by 6. We have 6 times 9, and we can see easily that the difference between 6 and 9 is 3. Now we need to make the one with the highest absolute value positive. So the 9 would be positive, the 6 would be negative, right? Because 9 minus 6 is equal to a positive 3. So negative 6 times 9 is equal to a negative 54. So these are the factors that work Okay, so negative 6. So that gives us b minus 6 times b plus 9. Now, it really wouldn't matter if you wrote b plus 9 times b minus 6. I don't, because multiplication is commutative, either or order you put the factors in. But if you want to double check it, the first ones would give you the b squared, then the outer ones give you a 9b, and the inner ones give you a negative 6b, and then the last ones give you the negative 54, and you know that 9b minus 6b would give you a positive 3b. So you can always do a mental math check of your work to make sure that you have the right factors. Okay, for number 8, I'll do this little diamond pattern above it. We're looking for factors of negative 2 that sum to negative 1. So, well, the factors of 2 or negative 2 are going to be 2 and 1. And since the sum has to be negative 1, remember we want the highest absolute value to be negative. So that makes this one negative. So we get y minus 2 and y plus 1 would be our factors. And then again, you could just check it by FOILing it. Doesn't matter the order that you put those in. Looking at number 9, why don't you go ahead and tell me which two factors we would use. We want factors of negative 18 that would sum to a positive 3. What are the two factors? So if I make my little x, I have my negative 18 here and a positive 3 here, and I'm looking for two factors. 6 and 3 are factors of 18 that have a difference of 3. So 6 and 3. Now, one of them has to be negative in order for the product to be negative. Since this is positive, the highest absolute value has to be positive. So that gives me a negative right here. So u plus 6 times u minus 3 would be my two factors that I would want to use. Okay, positive 6 and a negative 3. All right. Okay, and finally, we are going to be putting this all together with what we learned about solving equations. And now we're going to solve the equations, and they're in trinomial form. So the first thing we're going to have to do is factor them. So we want to factor g squared minus 13g plus 40. And so we're looking for factors of a positive 40 that will sum to a negative 13. So factors of 40, and I would guess probably 8 and 5. 8 and 5 would be my guess. And in this case, because it's a positive 40 and this is negative, they're both negative. So we would get g minus 8 and g minus 5. And that's equal to 0. So all we've done essentially is factor the trinomial into two binomial factors. Now, if you remember the zero product property, one of these factors has to be equal to 0. So g minus 8 equals 0, or g minus 5 equals 0. So again, we're adding 8 to both sides. So g is either equal to 8, or adding 5 to both sides, g is equal to 5. And so those are going to be the two situations that would make this equation true. Okay, for number 14, looking for factors of 6 that will sum to a negative 5. So factors of 6 that will sum to a negative 5, if this is positive, it's either both positive or both negative. And since this is negative, we know we're working with negative factors. So when you think of your factors of 6, it's 1 and 6, 2 and 3, and 2 and 3 would fit the bill here because of 5. Make sure that they're both negative so that you get k minus 2 times k minus 3, and those are equal to 0. So either k minus 2 is equal to 0, or k minus 3 is equal to 0. So when you solve this, you want to add 2 to both sides. So we'll get k is equal to 2, or k is equal to, in this case, you'll add 3 to both sides, equal to 3. 2 possibilities that would make this true. And for number 16, it's not equal to 0, but we could simplify this or just subtract 30 from both sides in order to get it equal to 0. So we would have x squared minus x minus 30 is equal to 0. Now we can factor this trinomial in which we want to find factors of a negative 30 that sum to a negative 1. Negative 30 that sum to a negative 1. So you start thinking about all the factors of 30. There's 1 and 30, 2 and 15, 3 and 10, 5 and 6. 5 and 6. Those are close together. 5 and 6. Now, one of them has to be negative if this product is negative, and you want the highest absolute value. So there you go. We would have x plus 5 times x minus 6 is equal to 0. So we would either have x plus 5 is equal to 0 or x minus 6 is equal to 0. Here, we would subtract 5 on both sides. So x is equal to negative 5, or we would add 6 to both sides. It's equal to a positive 6. Okay. And I'm going to let you work out problem number 17. Go ahead and solve the equation. Make sure that you put it in the right form first so that you have it equal to 0. And good luck.